Today's lesson is on multiplying rational numbers. This is part 1. Today we're going to multiply decimals. To multiply decimals, you simply multiply the two decimals, and then you decide which sign the answer will be. If we have the same signs, we will have a positive answer, while if we have different signs, we will have a negative answer. Let's go ahead and get started. In the first problem, it looks like we have a number that has 3 digits and a number that has only 2 digits. We also have one that's negative while the other is positive. So when we have different signs, we know our answer is going to be negative. So I would go ahead and start by putting the number that has the most digits on top. Again, we have 1, 2, 3 digits, while this one just has 2 digits. Now when we multiply decimals, you do not line them up at all. You decide when you have your final answer where to put the decimal. So it's okay that these are not aligned. Let's begin with the 1 here. We're going to multiply this 1 times every number above it. So 1 times 2 is a 2, 1 times 4 is 4, and 1 times 2 is 2. When we move to the 3 and we multiply it times every digit, we do have to move in one place value on our second line. So we're going to move in and put a placeholder of a 0 there, and we're going to start with this 3 times 2 is 6. That same 3 times 4 is 12. We'll carry the 1. 3 times 2 is 6 plus 1 is a 7. From there, we're just going to add straight down. 0 plus 2 is 2. 6 and 4 is 10. 4 plus 1 more is 5, and a 7. Since we have 3 digits that were behind the decimal up here, we have a 1 that's behind the decimal, and a 2 and a 4. Altogether, that's 3 numbers that are behind the decimals. So that means we're going to move the decimal from this far right over 1, 2, 3 place values. So our final answer is 7.502, and then we have to add a negative sign. And there we go. I'm going to circle that because a negative times a positive is always a negative. In the second example, we have a number that has 3 digits while this one has only 2. So we're going to place the 51.2 on top because it has the most digits, and 1.6 beneath it here, and we are multiplying. I already know that I'm going to have a negative answer because I have different signs here. And when we have different signs, it's always a negative answer. So let's start with the 6. 6 times 2 is 12. I'm going to carry the 1. 6 times 1 is 6, plus 1 is 7. When you're done with the numbers that you carry, you might cross them out so you don't get confused later. That same 6 times 5 is 30. Now I'm going to move to my second line, and I'm going to again put a placeholder here so that when I move in, I'm going to put 1 times 2 right there is 2. 1 times 1 is 1, and 1 times 5 is 5. Go ahead and add those up. I get a 2, a 9, a 1, and an 8. And we have 2 numbers that were behind decimals, so I'm going to start here and move over 1 place value and 2. So I have an answer of 81.92. However, because we multiplied a positive times a negative, whenever I have different signs, I must include a negative in my answer. The third example, we're going to put the 2.42 on top because it has 3 digits, while the 6.2 only has 2. I'm going to start and multiply those. 2 times 2 is a 4. 2 times 4 is 8. 2 times 2 is 4. Again, I have to move in a place value, so I'm going to put a 0 for a placeholder under the 4. I'm going to start with this 6 times this 2 is 12. Carry the 1. 6 times 4 is 24, plus 1 more is 25. Carry the 2. 6 times 2 is 12, plus 2 more is 14. Then I'm going to add straight down. 4, 10, another 10, a 5, and a 1. And it looks like we have 3 numbers that were behind a decimal, so I'm going to move it over 1, 2, and 3. I had the same signs when I multiplied, so that means this answer is going to stay positive. It is 15.004. Okay, so let's take a look then at some more. And this time we don't just have 2 numbers we're multiplying, we actually have 3 in both examples. So we can do what we did on the multiplying integer video. We started by multiplying the first 2 and then we multiplied the third one. The rules are still the same. When you have the same signs, it'll result in a positive answer. If you have different signs, it's a negative. So I'm going to start with these 2 right here, and I'm going to go ahead and multiply them. So they both have 2 digits, so it doesn't really matter which one I put on top. So I'll put the 3.2 there, and then the 2.1 right below it. Since I am multiplying, it doesn't matter that they line up or not. 1 times 2 is 2, 1 times 3 is 3, 2 times 2 is 4. Remember, there's a placeholder of a 0 there, and 2 times 3 is 6. If I add those up, I get 672, but I have to still put in my decimal, and it needs to go right there. Since one number there was negative while the other is positive, this is really a negative answer so far, but I still need to multiply it times this 7.4. So I'm going to take that 6.72 and now I'm going to put a 7.4 down here and continue to multiply. I do know my answer is negative because I'm taking a negative number times a positive, and when the signs are different, it is a negative answer. So 4 times 2 is 8. 4 times 7 is 28, and I'm going to carry the 2. 4 times 6 is 24, plus 2 more is 26. 7 times 2 is 14. There's my placeholder again. Carry the 1. 7 times 7 is 49, plus 1 more is 50. Carry the 5. And 7 times 6 is 35, plus 5 more is 40. So I'm going to add one more time. I've got an 8 here, a 12, 7, 2, and a 4. Now for this decimal, I need to look back at this number right here and this number that I multiplied it by. It looks like I have 3 numbers behind a decimal, the 7, 2, and 4. So I'm going to move it over 1, 2, and 3. And since I multiplied a negative times a positive, it is a negative answer. So I'm going to bring it over here so you can see it better. It's negative 42.728. Now, since you guys all have a calculator, or you can look one up on the internet, you can always check your answers if you'd like to. I definitely want you trying them by hand and then going back with a calculator and checking it. Even I do that to make sure that I am correct. Okay, let's go on to the next example. I'm going to multiply these 2 together, and then I'll multiply it times the third. It looks like I'm going to have a negative answer, but then when I multiply it times this one, I will end up with a positive in the end. Okay, since 6.41 has the most digits, I'm going to put that on top and multiply it times 1.4. So I get a 4 here. This is 16, carry the 1, 24 plus 25. Move in 1 digit, and I'm going to start here. 1 times 1 is 1, 1 times 4 is 4, and 1 times 6 is a 6. When I add those up, I get a 4, a 7, a 9, and an 8. And since I had 3 digits behind the decimal goes right there. I'm going to bring that up here now, and I'm going to multiply that 8.974 times my last number right there, 7.7. Okay, 7 times 4 is 28, carry the 2. 7 times 7 is 49, plus 2 more is 51. Since I used that 2 already, I'm going to cross it out so I don't get confused later. 7 times 9 is 63, plus 5 more is 68. Cross that out, carry the 6. 7 times 8 is 56, plus 6 more is 62. So there's what I have so far, and now I'm going to move in one line item. So I'm going to put a 0, and I'm going to start with this 7. 7 times 4 is 28 again. Carry another 2. 7 times 7 is 49, plus 2 more is 51. Carry the 5. 7 times 9 again is 63, plus 5 more is 68. Carry the 6. 7 times 5 is 56, plus 6 more is 62. And you could have looked above because we had the same numbers we multiplied. Add straight down, and it looks like we are going to end up with 690998. Since we had 4 numbers this time behind the decimal, I'm going to move over 1, 2, 3, and 4. And we said earlier that we had a negative times a negative, so that remains positive. Let's check out a couple story problems now. We have an investor that owns 203.72 shares of Glacial Futures stock. The value of a share of stock drops 15 cents. This 15 cents, since it's dropping, is actually going to be a negative number. Since it's 15 cents, that decimal is super important. Find the total change in the value of the investor's stock. So we're going to take the number of shares the investor has, and we are going to multiply it times a negative 15 cents. So there's what it would look like when I set it up. If I'm going to do the problem, I'm going to take 203.72 and put that on top and multiply that times 15 hundredths. I know my answer is going to be negative because I have a positive number times a negative number. So a little multiplication here. It looks like I am going to end up with 101860 on the first line. And then I need to move in right here. So I'm going to put a placeholder there. And that's going to be a 2, a 7, a 3, a 0, and a 2. Adding straight down. Looks like I have quite a big number here, but I've got to place my decimal in. So it looks like there's 4 digits. They're right here that are all behind a decimal. So I'm going to move over 1, 2, 3, and 4. Now that leaves me with 30.558. Now since we're dealing with money, because we are talking about the value of stocks, I'm going to round this to the nearest cent. So I know I've got a negative $30 here, and I want to round it so it only includes the change part here. So since we deal in dollar and cents, I'm going to look over here at this 8. Since this is an 8, this is going to be rounded up to a 6. So to the nearest cent then, this is how much money we've actually lost on the value of our stocks. Last example is talking about temperature. Suppose there is a 1.1 Fahrenheit drop in temperature for every 1,000 feet that an airplane climbs into the sky. If the temperature on the ground is 59.7 degrees Fahrenheit, what will be the temperature when the plane reaches an altitude of 11,000 feet? Well, to first figure out how many feet I'm talking about here, I'm going to take that 11,000. Since it says that the temperature is going to drop 1.1 for every 1,000, let's see how many thousands I actually have in 11,000. Well, if you've quickly done that, that's actually 11. So I need to take that 11 times a negative 1.1, and that's because this is dropping for every 1,000 feet. So if I set this up, doesn't matter which one's up there on top, which one's below, because they both have 2 digits. So if I do this multiplication really quickly, you can see I end up with 12.1. And it does have to be negative since one number is negative while the other is positive. So that means this is going to drop a total of 12.1 degrees Fahrenheit. So if I go ahead and figure out what the temperature is actually going to be then, I need to take my 59.7 and subtract my 12.1. It looks like the temperature then is going to be 47.6 degrees Fahrenheit. And we're done. Hope you enjoyed this video.